the final thing I want to talk you through is velocity time graphs with a bouncing ball. And this is really quite high level stuff, but it has come in an exam paper before. It's normally in A-level, but they've now brought it down to GCSE. So I'm going to take you through this and then show you an exam question, which is not as tricky as you think, but it's understanding the graph. So first of all, we've got velocity on this axis and we've got time on this axis. And what this graph does is it shows, or it represents, the velocity of the ball from when we drop the ball at this height to when it bounces back again. So let's have a look. First of all, we are making going down a positive velocity, which means that this axis up to here means the ball is going down. Remember, if the velocity is negative, it means it's going the opposite direction. So this is the negative velocity, which means the ball is coming back up the other way. So that's the first thing to get your head around. We also know the gradient of velocity time graph is acceleration. We release the ball at time equals 0 at some height above the ground. And you can clearly see the ball accelerates straight away at a constant acceleration, which is acceleration due to gravity. And that should be 10 meters per second every second. So if you have a look, the gradient here is going to be equal to the acceleration, which is change in velocity over the change in time. And you can see the change in velocity up to 2 when it touches the floor, when it just makes contact with the floor. The change in velocity is 3 and the time taken was 0.3, and you can see that gives us 10 meters per second squared. That's the acceleration due to gravity. Now you can see when it hits the ground applies a whacking great big force up and decelerates the ball really fast. And at 3, that ball is actually squashed on the floor, and now it has got 0 velocity and it has stopped at 3. But now it's storing elastic potential energy, and so as it expands, it accelerates again, so its velocity increases until 4. And at 4, it just leaves the ground. So imagine at 4, it's just leaving the ground. And of course, it's only being accelerated back the other way while it is touching the ground and the ball is expanding again. So if you watch this quick film I found and slowed it right down, you can see that the tennis ball, when it hits the ground applies a force and squashes the ball, decelerating it very fast. Now the ball is stationary and then starts to accelerate again upwards. The ball applies a force to the ground applies an equal but opposite force and starts to accelerate it upwards until it leaves the ground, when it then starts to decelerate again due to gravity. Watch again without me interrupting and pausing parts of it. So at 4, it leaves the ground. And notice it leaves the ground at a lower speed than it hit the ground, because you've lost some of that kinetic energy into heat. And so it doesn't leave the ground with as much velocity as it hit the ground. But as soon as it leaves the ground, it's going to start to slow down and it decelerates. Can you see the speed is getting less? And it decelerates back to where it is stationary at 5. So that's where it's back at the same position again, where it is stationary. But it's not as high up anymore because it lost some energy when it hit the floor. And this gradient here is the acceleration due to gravity, but it's decelerating it. So you can see that is equal to, well, it's going to be change in velocity over time. The change in velocity is 2 and it's minus 2, and the time taken is 0.2, and you can see that's minus 10 meters per second squared. It's minus, meaning it is slowing down, it's decelerating. And when it gets up to 5, the cycle starts again. It stops and then starts accelerating again, and you can see the cycle starts again. So one other thing is this. Remember, the area under a velocity time graph is distance travelled. So the area under there, the distance travelled between 1 to 2 is the height. Now, they would never expect you to work all of that yourself. It would have to be a scaffolded question. But let me give you an example of one that they've done before. Now, of course, had you never been told this or shown this, this might take you by surprise. But it says a child drops a ball. The ball hits the ground and bounces. The graph below shows the velocity time graph for the ball from when the ball is dropped until the ball reaches the top of its first bounce. Ignore air resistance. So it's being dropped. So at point A, it's high up. It then falls under gravity and hits the ground at B. It decelerates very quickly, and then it leaves the ground at C with a lower speed than it hit the ground out. Can you see that? And then it slows down, decelerates, and doesn't get as high, and it stopped back at D. So it says describe the motion of the ball between points A and B on the graph. Well, that's okay, because it's a velocity time graph. So part A is travelling at a constant acceleration. So you may get the 2 marks for saying constant acceleration. But describe the motion, you could calculate it. Remember, there are 5 squares in 2, so each square is worth 0.4. So the change in velocity is going to equal 6.48. That's exactly 7. So change in velocity is 7. Over the time taken, well, that is also 0.7. It's midway. And so that is 10 meters per second squared. So that's describing it, because you've also done a calculation. It's a constant acceleration of 10 meters per second squared. And then part B, what direction is the ball moving between C and D? Well, of course, this is positive velocity, which is going down. This is negative velocity, so it must be moving up rather than down. Part D, I don't know why we haven't got part C, but part D. When the ball hits the ground, energy is transferred from the ball to the earth. Explain how the data in the graph above shows this energy transfer. Well, of course, the data is that it hits the ground at 7 meters a second, and it rebounds at only 5 meters a second. And it's worth 4 marks, so you've got to get all these marks. So the first mark may be the ball hits the ground at 7 meters per second and rebounds at 5 meters a second. So for the next mark, it has clearly lost some kinetic energy, and the kinetic energy is transferred into heat. You could also say and sound. So that's why it doesn't leave at such a high speed.